Hello and welcome to the next session. Now, today I am going to talk about supporting technology for our data science, one of the technology which we are familiar, some of us are will be familiar and some of may be new for it, data mining and data warehousing concepts and techniques. So, the discussion will be on most of the under data mining under data science team or data science project. So, let us go in detail, but before I go into detail, let us see what the buzzwords are there nowadays in the market and why data science is more popular and why big data or data analytics or data mining techniques are very useful. So, we have some of us have already heard the term big data analytics. Big data means the data is of the order of not terabyte but exabyte, that is a 10 raised to power 18 or 20 or even bigger. So, we have something called as big data analytics where the profound things is happening because of the disruptive technology factors which we already know. Mobile is a disruptive technology, cloud computing is a disruptive technology, social media like Facebook, Twitter, so many are available as a disrupting technology, and finally I have a IoT. So, everybody is talking about big data analytics, but we are not going to into have a big discussion on the big data analytics because it's itself is a big code. But what I mean to say is here, when the amount of data is very large and it can't be handled by a single CPU or a single website or single or multiple number of resources are there for collection of the data. For example, I want to do a social media analysis, so Twitter, Facebook, so many other are there and I want to do a analysis like LinkedIn analysis or any other, then the data volume or data size become very large, and when it become very large, a single CPU or single site cannot be able to handle. So, we have a big picture called as big data analytics. So, this is the background of that. And Google is very famous for doing a big data analytics, but what he says that Eric Schmidt, from the dawn of civilization until 2003, humankind generated 5 exabyte of data. Now, exabyte is okay, so very large data. Now we produce 5 exabyte every 2 days. So, look at the volume of the data which is being produced nowadays. So, he is saying that in 2003 the data was created, okay, 5 exabyte, but now we are producing 5 exabyte every 2 days because of the social media, because of this thing, okay. And you can see here exabyte is almost is equal to 10 raised to power, okay. So, 6, okay, 1000 raised to this thing exabyte, okay. So, these are all the metric of our decimal system to measure the big data analytics. Now, before big data analytics, let us go into what we call as data analytics, and then I will go to data mining. So, domain of non-personal big data analytics are very extensive and very large. For example, CERN, Center for Nuclear Physics, have a LSC, Large Hadron Collider project, astronomical square kilometer array, genomics, DNA sequencing, cognitive science, brain mapping, meteorological department, intelligent machine. These are all the applications of big data analytics. Okay, and the domain for personal big data also is expensive. Like example, political science, social, commercial, Amazon, Google, eBay, Walmart. Domain for global big data analytics is also surveillance, operational, electrical grids. So, let us see some application, then I will go to what we call as a data mining. Smart healthcare, multi-channel, finance, log analytics, homeland security, traffic control and system, telecom industry, search options or search quality options, manufacturing, trading analysis, fraud and risk detection, and retail churning out or NBO. Now, with this have some idea about what is the data is all about, and then we will go to data mining as one of the technique. So, everyone can develop and leverage big data. Big data tools are visualization tools available, monitoring tools are available, development tools are available, and we have managing of the data science where we have to probably manage maybe a large amount of data or maybe a mediocre of the data. So, So you can see here there are some potential applications and people who are using the big data analytics, like business users, business developer, data scientist, executive leader, developer, business analyst and administrator. So this slide gives you a overview about the big data analytics and the people who are being using the data mining technique for it. So what is data mining? I have to mine some data. I have to look for some particular pattern. So motivation for data warehousing and data mining is motivation. Why data mining? What is data mining? And on what kind of data I am going to put mining efforts? And what are the functionality of my mining? And how do I classify my mining system and some issues in the mining system? So let us say, what is data mining? So as I just now said, we have a big data analytics. So what do I mine? Explosive growth of data from the terabyte to a petabyte or even petabyte and even more. So data collection and data availability is where automated data collection tools are there, database systems are there, web page applications are there, computer society, and so many applications are there. So I am getting a lot of data from the collection. I am getting a lot of data from the insurance sector as a database. I am getting a lot of Twitter account and all the web details available, and from so many sources. Major sources are abundant for the data. Business, so e-commerce, transaction, business, stock exchange. So everybody is involved in, starting from the banking application to the trading application. Business. Science, remote sensing, bioinformatics, scientific simulation. Then society for everyone, news, digital camera, YouTube. So you can see here the application domain tells me what kind of data I am going to mine. Okay, so we are drawing in data but starving for the knowledge. So this is a basic underlying principle of my data science or data mining. We are drawn in the data. I do not know where I am, but we are striving for the understanding of the knowledge. And the very big saying, which is a very old saying also, necessity is the mother of invention. It is very true in case of a data mining. Okay, so because I want to have a automated data mining, so I have to deal with the massive data set. So that is the first principle in our data science too. Okay, necessity is the mother of invention. So what is data mining? Data mining is discovering of a knowledge from the data. So I have, let us say, 1 million users in my bank account. Out of 1 million users, who are the frequent user of my banking application? Who are the frequent buyers of the particular commodity from the eBay or from any of the e-commerce website? Okay, so I want to extract some knowledge and some pattern. Based upon the knowledge and pattern, I require some understanding about the behavior analysis, about the pattern of the people who are spending the money, about the churning ratio, about the loan disbursement. All this information are required for a data mining purpose. So alternate name for a data mining is knowledge discovery, okay, knowledge extraction, data pattern analysis, data dredging, and data information harvesting. These are all some of the alternative words, but most conveniently people use the word data mining throughout the discussion, and I am also going to use the data mining as one of the name for us. So watch out, is a start, everything is start simple search queries, not a data mining, but still we put a word because we are trying to find out some pattern. Okay, so a expert system or a deductive knowledge also is a data mining. Now look at the process of my data mining. I have a database. I have a large amount of data, and let us take a banking application. The banking will have millions of the customers as a database. Okay, then I'll get all the data to be clean, because everybody will have a phone number, account number, this number, that number, house number, type of transaction, account detail like saving account, current account, all those information, and they have to be put into a cleaner order form. So anyway, data cleaning is one of the method where you have a raw data available, put into a put into a hard disk and clean that. Then I'll have a word called a data integration. So I'm coming from different sources of the data. For example, different branches or different banks will have a different way of storing the information, storing the data. So I have to integrate all the data put together, and all this information will go into a data warehouse as a repository. So in our classical database, I have a database as a repository. In a data warehousing and mining, I have a warehouse. That means a very big chunk of the data will be stored. So I have a term called as a data warehouse. From here, I'll take the data which is relevant to my relevant to dig. So data warehouse is to be updated not every day, but maybe updated periodically, maybe once in a 7 week time or month time and things like that. And most of the information available in the data warehouse, they are not to be changed. Okay, they are there for the purpose of extracting the knowledge. So I have data warehouse. From the data warehouse, I have a task relevant data. So I can go for a task relevant data. For example, I want to know how many people have account, which is how many number of accounts are there where the minimum amount of balance is kept is equal to 50,000 or maybe 1 lakh, or how many people who have a salaried account. So these are all the task relevant data available to me. After that, I'll select and put the information into a mining pattern. So I have from the warehouse, I'm selecting our relevant data, I'm putting into a mining. So what is mining now? Very simple. You extract some information from the data warehouse, put them into an order form and put them into a graphical representation form. And once you put into a graphical representation form, we are able to discover a particular pattern. So you can see a histogram of a particular pattern, and from the particular pattern I'll be able to derive a knowledge. So starting from my databases to the knowledge discovery, this is what we call as a knowledge discovery process, or what we call as a knowledge discovery, or in short it is called as a KDD, knowledge discovery data or knowledge data discovery. So you can see here data mining is a core of my knowledge discovery. So what is the knowledge I have discovered? The knowledge I have discovered from the insurance company or from the banking sector is how many people have this kind of account, how many people are likely to buy this kind of product, or how many people are going to churn out and things like that. Okay, so this is what we call as a KDD process. And if you look at the some business intelligence, okay, data mining as business intelligence. Business intelligence is also coming up very frequently, and we use the data analysis or data mining technique along with the business intelligence. Business intelligence tells me the extraction of information for doing a particular business. For example, how many people are having a cancer. So I want to do a analysis of patients who are coming to my clinic or coming to hospital, and then find out how much what is the stage of the cancer they have. So let us look at the what we call as a business intelligence process. I have paper, file, web document, scientific experiment, database system. So this is what we call as the data sources I have. Then I will process the data, I will clean the data, put them into a data warehouse. From the data warehouse, I put a query. So statistical summary like mean, median, all those things we know very well. We have already done the exploratory data analysis. So I put them, and then I go with the data exploration. So querying, report, everything. From there, I will go with the data mining, and from data mining, I go to the data presentation, and then finally it comes to the decision making. So this is what we call as a one of the example of my this thing. And let us cut short and see what the data mining is on confluence of. Data mining is a multiple discipline. It consists of statistic, visualization, other disciplines, algorithm, pattern recognition, machine learning, database. So you can see here around 7 number of blocks are there, where each and everything is collected with the data mining. So a database technology will also have it, statistical tools I am going to use it, visualization techniques I can use it, any other discipline like mathematics, physics, other disciplines also I can mine the pattern. Then I am going to talk about some of the algorithm, and what is very important, which is the next section, next session maybe I am going to talk about pattern recognition. How do we recognize a pattern? Of course, we know machine learning and database technology. So with this I stop here, and thank you.